In the end of a logic design lecture, a professor challenged his class to make an SR latch. He gave every student two push buttons, a box full of LEDs, and two input logic gates like AND, NAND, OR, and NOR. He told the students that the first push button will be used to turn on one LED, and the second push button will be used to turn it off. He also told them that they cannot push the two buttons together so that the LED won't burn. One of the students asked him, "What happens if no buttons were pressed?" He told him that the state of the LED will stay the same. The students began to think how they can build such a circuit, so they started to write a truth table that relates the LED status to the two buttons. If the set button was pressed while the reset was not, the LED will turn on. If the reset button was pressed while the set was not, the LED will turn off. If no buttons were pressed, the LED will keep its state. This means that if the set button was pressed momentarily, the LED will turn on and will never turn off until someone presses the reset button. That's why the circuit is called set reset latch. The output remains latched until the second button is pressed. Pressing the two buttons together is invalid, as the professor stated that this will burn the LED. This means that we can determine the output directly when only one button is pressed without looking at the second button, and that is because we are sure that the two buttons should never be pressed at the same time. Johnny, one of the students, started to build the circuit. He wanted to use a single 2-input logic gate by connecting the two buttons to the input ports and the LED to the output port of the gate. He started by trying an OR gate. He found that the reset button turns on the LED instead of turning it off. So he tried using an OR gate. He found that when the set button is pressed, the LED doesn't turn on. Johnny had only two choices left. He tried using an AND gate, but unfortunately he found that the set button cannot turn the LED alone. So he tried using an AND gate, and he also found that it doesn't work, as when the reset button was pressed, the LED turned on. Johnny surrendered and told the professor that he was unable to create an SR latch using two input logic gates. Meanwhile, Johnny's friend Sam noticed that the professor said a very important statement. The state of the LED will not change if no buttons were pressed. Sam concluded that there should be a feedback so that the LED maintains its state after a button is released. Sam noticed that he needed three inputs to create the SR latch: the set button, the reset button, and the feedback coming from the output. Sam was confused as there were no three input gates. He asked the professor if he could use two input logic gates. The professor nodded and congratulated him on solving the first piece of the puzzle. Sam had to use an extra LED and an extra feedback signal so that all input and output ports are connected. Sam now has two choices. He can either split the buttons on two logic gates or connect them to a single gate. His friend Johnny told him that he shouldn't connect both buttons to a single gate as it did not work for him. Sam told him that he was right, as each logic gate must have a feedback signal connected to one of its inputs. Both friends were a little hesitant as they didn't know whether the feedback should come from the output of the other gate or from the same gate. Sam decided that he should try first connecting each feedback to the input of the same gate, although his second friend Elon didn't agree, saying that this will make the reset button useless as it will have no effect on the first LED. Sam was not convinced and decided that he should try all four combinations of the logic gates. He started by trying AND gates, but they didn't work as when he pressed the set button, the LED didn't turn on. So he tried using NAND gates and pressed the set button, but the LED kept oscillating until it burned. Sam then tried using OR gates, but when he pressed the set button, he had no way of turning the lamp off as there was no feedback from the second LED. He tried using NOR gates, but when he pressed the set button, the LED didn't turn on. Sam realized that his technique would never work. Elon was right. The feedback should have been taken from the output of the second gate, not from the same gate. All eyes were now on Elon. The only thing left is choosing the correct logic gates so that the SR latch works as intended. Elon had 16 possible combinations to choose from. However, he looked at the circuit and decided to use identical logic gates to keep the circuit symmetric. This made the number of possible combinations 4. Also, he was confident that AND and OR gates can never be used in a memory storing feedback loop. Let me explain. If we use two AND gates and the set button was pressed, the upper LED won't turn on, and the signal will propagate to the lower AND gate. This will keep the lower LED off. Both LEDs will be stuck at 0 because the push buttons will have no effect on the output of the AND gates. Similarly, if we use two OR gates and the set button was pressed, the upper LED will be turned on and the signal will propagate to the lower OR gate. This will turn on the lower LED, so the two LEDs will be stuck at 1 even if the reset button was pressed. That's why we cannot use AND and OR gates to create an SR latch. Finally, only NAND gates and NOR gates were left. Elon analyzed how NOR gates operate and he noticed something interesting. He realized that the output of a 2-input NOR gate can be determined by looking at only one input. If that input is 1, then the output is guaranteed to be 0. But if that input is 0, the output becomes the inversion of the second input. Elon discovered a useful hidden feature in NOR gates. They behave like inverters when one of their inputs is held at 0. To verify his discovery, he connected a push button to a NOR gate and he pressed the button. He found that the NOR gate blocked the current, but when he released the button, he found that the NOR gate acted as an inverter. Elon connected the NOR gates and pressed the set button, but the upper NOR gate blocked the current from passing, so the upper LED didn't turn on. Elon was sad. He thought that his circuit didn't work, but suddenly something unexpected happened. The output signal propagated to the input of the lower NOR gate, and since the reset button wasn't pressed, the lower NOR gate acted like an inverter. The magic happened due to the feedback coming from the upper NOR gate, as the output of the lower NOR gate became the inverted version of the upper gate. This caused the lower LED to turn on. When Elon released the set button, he found that the state of the LEDs didn't change. This happened because the two NOR gates acted as inverters. You see, the cross-coupled feedback acts as a positive regenerative feedback. This means that it keeps the output stable. Since the lower LED is on, the upper LED will stay off as its state will always be opposite to the lower LED. Similarly, since the upper LED is off, it will keep the lower LED on due to the presence of the lower NOR gate, which acts as an inverter. Elon was happy as he remembered the professor saying that the output of the LED shouldn't change if no buttons were pressed. Finally, Elon pressed the reset button. The lower NOR gate blocked the current, so the lower LED turned off, but the signal propagated to the input of the upper NOR gate and the upper LED turned on. This happened as the upper NOR gate acted as an inverter because the set button wasn't pressed. Elon noticed that the lower LED always behaved the way the professor wanted, as it matched the truth table of the SR latch in all cases. So he removed the upper LED, put his circuit in a black box, and showed it to his professor. The professor tested Elon's circuit. He pressed the set button and the LED turned on. Then he released it and the LED kept its state. Finally, he pressed the reset button and the LED turned off, and after releasing it, it also stayed off. The professor congratulated Elon, gave him bonus marks, and declared that he was the only student that was able to create an SR latch.